In this video I explain my solution for question 2 of homework 3, where we are asked to find and draw the probability distribution function of y and the cumulative distribution function of x if x is uniform between a and b and y is equal to x squared. Now if x is uniform between a and b, then its PDF is as shown here, and if y is equal to x squared, then its sketch is as shown here. According to the fundamental theorem, we have fy of y is given by this equation here. This is between 0 and b squared. This is if b is greater than 0. And from this, given in the question, y is equal to x squared, if you make x a subject, x becomes plus or minus root of y. And if g of x is a function of the random variable x, and y is equal to g of x, then the first derivative is 2x. So substituting into this fundamental theorem, we get f of x at x1 as this, and the derivative at x1 as this. The same applies here, noting that this is a magnitude, so giving us same values here. Now, since f of x is given by 1 over b minus a here, then f of x at root y will be this, and f of x at minus root y will be this, and simplifying it just gives us this here as the PDF with respect to y. For the other values of y, the PDF will be 0. So the sketch of the PDF of y would look something like this. Now we are also asked to find the cumulative distribution function with respect to y and with respect to x, and this is simply the integrals of the PDFs from negative infinity to y, for example, using a dummy variable, and the same thing for x using a dummy variable as well. Now the PDF of x is 1 over b minus a, uniform between a and b, and this PDF here we've just derived it in the previous part, which is this, and therefore the integrals simply reduce to this and to this line for the x. The sketches are shown here, the CDF for respect to y from 0 to 1. Similarly for x, from 0, a line, and then 1. Now in the next part, we are asked to assume that a is equal to -1 and b is equal to 3. It simply becomes a substitution into the results above, and we get, for example, the PDF with respect to y with this curve, maybe with a different slope, and the CDF with respect to y given here as well with this function here. In the last part, we have to find the expected value of y, which by definition is this, but we know that this PDF is defined between 0 and 9, between 0 and b squared, which is this, and when you multiply that with y, we get this, and then we get a simple result here. The value of y becomes a simple integration, which is as shown here, and the substitution for the limits gives value of 4.5.